Here's my circuit. I'll show the readings first. So there's the scope all the way down, which is the max step of 12 centimeters. Then going to 6 centimeters. 12 centimeters, I adjusted the Wavegen so it does not go past 3 volts. The only thing I modified was the amplitude to 950 millivolts. So there's that. And then the putty readings. It's at max step. Then about halfway. There's 6. These markings are coming off, but they mark every 2 centimeters. Go into my circuit, unplugging the AD2. Except for these important plugs. So I have Wavegen plugged into here, go into the capacitor. Other side of the capacitor goes into pin 2 of the differentiating op amp. 1K resistor going across, another 1K resistor, 2.2K resistor, that's pin 2. Then going to the rectifier, and then the plus side is the output going across this capacitor. Then the microcontroller can read the ADC reading. Also, since the input to op amp 1 will be a sine wave, since it's differentiating, we'll have cosine. This is an inverting op amp, so this will be an inverted cosine wave. Then the rectifier will turn that alternating AC current into DC current for a microcontroller to read. Then here are my calculations. This is at 15 readings at the deepest length. Then I got the average or the mean of the values, calculated standard deviation, then got the confidence level, and then we have our lower limit, which we would have used for the website. These are the plot points for this graph. Here's height, ADC reading, and then this is the equation that I use for turning the ADC reading into a centimeter reading.